Geothermal energy, a reliable source for electricity generation. Geothermal energy, a reliable source for electricity generation. Introduction. In today's world, the search for sustainable and environmentally friendly sources of energy has become of paramount importance. With concerns about climate change and the dwindling reserves of fossil fuels, it is crucial to explore alternative energy sources that can meet our increasing energy demands. Geothermal energy is one such option that has gained traction in recent years. Harnessing the natural heat from within the earth, geothermal energy offers a reliable and renewable source for electricity generation. In this article, we will delve into the various aspects of geothermal energy, including its benefits, challenges, and its potential as a major player in the global energy landscape. Understanding geothermal energy. Geothermal energy is derived from the heat contained within the earth. It is a renewable resource because the earth's internal heat is essentially limitless. This energy source originates from both primordial heat left over from the planet's formation and the decay of radioactive materials within the Earth's core. The heat moves towards the surface of the Earth through conduction, causing temperatures to rise in certain areas. Harnessing geothermal energy. The extraction of geothermal energy involves tapping into underground reservoirs of hot water and steam and converting it into electricity. This process requires drilling deep into the Earth's crust, commonly referred to as geothermal wells. The hot water and steam in these reservoirs are brought to the surface through the well and used to generate electricity. After use, the cooled water is injected back into the ground, thereby replenishing the reservoir. Benefits of geothermal energy. 1. Renewable and sustainable. Geothermal energy is a renewable resource as it taps into the Earth's natural heat, which is continuously replenished. This makes it a sustainable energy source that can be used for generations to come. 2. Clean and environmentally friendly. Unlike fossil fuels, geothermal energy does not produce greenhouse gas emissions. The power plants that harness geothermal energy have minimal impact on air quality, reducing the negative effects on climate change and air pollution. 3. Consistent power generation. Unlike other renewable energy sources like wind and solar, geothermal power plants operate continuously, regardless of weather conditions. Geothermal energy can provide a stable and reliable baseload power supply, making it a dependable source of electricity. 4. Cost-effective. Geothermal energy has the advantage of low operational costs once the initial infrastructure is set up. The relatively consistent temperatures underground mean that maintenance costs are minimal compared to other forms of energy generation. Challenges and limitations. While geothermal energy has numerous benefits, it is not without challenges and limitations. 1. Location-specific. Geothermal resources are not uniformly distributed across the globe, but rather concentrated in specific regions. Therefore, infrastructure development becomes limited to these areas, which could be geographically remote and necessitate long-distance transmission lines. 2. Exploration and drilling risks. The success of a geothermal project heavily relies on accurate exploration and drilling. Drilling deep into the Earth's crust is a complex and expensive task, with the possibility of encountering unexpected geological conditions that may render the project unviable. 3. Environmental concerns. While geothermal energy is considered environmentally friendly, there are potential risks associated with the extraction process. The release of toxic minerals and gases too. Ring drilling and the disposal of geothermal fluids need to be carefully managed to avoid contamination of surrounding ecosystems. 4. Initial capital investment. Developing geothermal power plants requires significant upfront investment in exploration, drilling, and infrastructure development. These initial costs may deter some regions from pursuing geothermal energy options. Global potential and future outlook. The global potential for geothermal energy is vast. Countries such as Iceland, the Philippines, and Kenya have already successfully integrated geothermal energy into their electricity generation mix. However, there remains untapped potential in regions like Central America, East Africa, and parts of Southeast Asia. To fully maximize the potential of geothermal energy, governments and organizations need to incentivize its development through regulatory frameworks, financial support, and technology advancements. Continued investment in research and development is crucial to improving exploration techniques, reducing drilling risks, and enhancing the overall efficiency of geothermal power plants. Geothermal energy has the potential to play a major role in our energy landscape due to its reliability and its ability to meet our increasing electricity demands. By harnessing the Earth's natural heat, geothermal energy offers a renewable source of power that has various benefits. One of the significant advantages of geothermal energy is its renewable and sustainable nature. The Earth's internal heat is continuously replenished, making geothermal energy an abundant and long-term resource. Unlike fossil fuels, geothermal energy does not emit greenhouse gases, making it a clean and environmentally friendly option. This greatly reduces its impact on climate change and air pollution. Moreover, geothermal power plants operate consistently, providing a stable and reliable baseload power supply. Unlike wind and solar energy, which are dependent on weather conditions, geothermal energy can generate electricity continuously. This consistency ensures a dependable source of power, especially in areas where weather fluctuations may affect the generation of other renewable energy sources. In terms of cost-effectiveness, geothermal energy has a significant advantage. Once the initial infrastructure, such as geothermal wells, is set up, the operational costs are relatively low. The cons: temperatures beneath the Earth's surface require minimal maintenance in comparison to other forms of energy generation. This makes geothermal energy a cost-effective option in the long run. However, there are challenges and limitations associated with geothermal energy. One of the main limitations is its location-specific nature. Geothermal resources are not evenly distributed worldwide, but rather concentrated in specific regions. This geographical concentration limits infrastructure development, as it requires long-distance transmission lines in some cases. Another challenge lies in the exploration and drilling process. Successfully extracting geothermal energy relies on accurate exploration and drilling techniques. This can be complex and costly, with the potential for encountering unexpected geological conditions that may render a project unviable. Additionally, careful management of exploration and drilling processes is necessary to prevent the release of toxic minerals and gases that could harm surrounding ecosystems. The upfront capital investment required to develop geothermal power plants is also a limitation. Exploration, drilling, and infrastructure development entail significant costs. This may deter some GINs from pursuing geothermal energy options, especially those with limited financial resources. Despite these challenges, the global potential for geothermal energy is substantial. The International Renewable Energy Agency estimates that the technical potential for geothermal power generation worldwide is around 200 GW, with only a fraction currently being utilized. Countries like Iceland, the Philippines, and Kenya have already successfully integrated geothermal energy into their electric generation mix. To fully unlock the potential of geothermal energy, governments and organizations need to incentivize its development. This can be achieved through regulatory frameworks, financial support, and tech